live. Great. All right, for Candy, what partnership out there? You and your partner spoke about seeing the pattern, noticing the pattern. In fact, let's just get rid of this for a second. So noticing the pattern, we have a matrix here, and the -1, remember, denotes an inverse. So the inverse, we go from here over to this side. First, somebody tell me what is under the fraction right here. What is that we have under the fraction? We saw it yesterday. What's it called? Starts with a D? Determinant, right? Remember the determinant? We multiplied in the cross fashion here. 3 times 1 minus 4 times -4. So that's a component here. There's a determinant. Who else can see a pattern? I'll let you guys answer now. What's another pattern you guys see? Any team see anything? It's kind of creative. You have to get creative. Yeah, Andre.
Well, from the first matrix to the second, A and D switch positions, but then B and C switch just signs.
Good. Perfect. So A and D switch positions, but let's see, B and C, they're just switching the signs. And we have to, there's a way we're going to remember that. It's a mnemonic device we'll use. That's exactly correct. Perfect. All right, I'm going to pause because we're going to copy down some notes. Thank you. All right, we're back. We're looking at, well, really, we're looking at the inverse of the matrices. But the only reason we're using that is to solve a system. So by the end of this lesson, we're going to be able to solve this system using a matrix and a few matrices. But we're going to end up working out through some matrices, and we'll end up with a matrix that has our x and our y value. It's going to be kind of miraculous. It's an entirely different method to trying to find a solution. So first off, the inverse is going to be key to doing this. And the reason why is because if we have a regular, right? If we have a regular equation like so, how do we solve that? What do we do? Why are we dividing by 2? Because it's exactly, that's the y. And the process of it actually eliminates and isolates the variable by multiplying by the inverse. The inverse of 2 is 1/2, right? The inverse operation multiplication is division. So we use the inverse all the time. We're just going to be doing that with an entire matrix. To get rid of a matrix on the left side, we use the inverse. It will negate that out. All that's going to be left over on the left side is our variables. So you see here, all I really had to do was multiply by 1/2. You could think of it that way, or divide by 2, same thing. Multiply by 1/2. Those are gone, so we get x equal to 5. So this process is really what we're going to do today. That's what we're going to accomplish. The notation of an inverse is a to the -1, so it's pretty basic. We've seen that before. And the definition of it is if you take the matrix and you multiply by the inverse of the matrix, you get the identity matrix. Okay. And that's really what we did. Here, these don't just disappear. You know, this part didn't disappear. 2 times 1/2, right, is equal to 1. It's equal to 1. And that's what we would find, just like we do here, that 2 times 1/2 is 1. And that identity matrix is basically going to negate out an entire matrix just with one swoop. So if we first need to find the inverse, which we're going to do first, here we have A is equal to A, B, C, D. The inverse of matrix A is going to be A times D minus BC on the bottom. That's a determinant. So we have a fraction like so. And then, Andrea, what was the change again for that second matrix? Is derived from A. What happens here again?
So A and D switch positions, and B and C switch signs.
Perfect. A and D, thank you. A and D switch positions. B and C switch signs. So my student teacher actually came up with this one way to remember it. I'm determined to switch the AD on TV when it's negative just because. And because is BC. You know, you write it because. So anyway, that's one way to remember it. You can do another mnemonic device. On your notes, you can write this so you remember it. I like it. I like it. So let's work on this together. We have our matrix A. Let's go ahead and put our inverse right below it. So first off, what do we need to do? I want you to put the first component. We're going to end up with a fraction, and we're going to end up with a matrix. And I want you to go ahead and do the first step. Let's go ahead and put in that determinant. It's over 1 or under 1. And then switch up the matrix. So if you worked it out all the way or not, let's go ahead. For those at home, somebody help me out. What is going to be multiplied? What two products actually are going to be subtracted from each other here? Jackson, what do you think?
1 and 4.
1 times 4?
Yeah.
Minus?
Minus 2 times 0.
2 times 0. Okay. So you see, we set up the first part here. All right, let's see. Ian, can you help me with this part? What's going to go in this matrix to find our inverse from our matrix A?
4, 2,
0 and what?
the 2 and 0.
Well, if we look here, remember if matrix A has CD, or CB like this, BC, then over here, they don't switch position, they're just going to switch the sign actually. So do you mind, I could leave it like this? Because let's see what happens. A and D switch, B and C just switch the sign. Good to go? So let's go ahead and just work this part out. What is 4 minus 2? 1/2. Now, yes?
Wait,
Wait,
2
hands went up. 3 hands went up. Yeah, Jackson,
2
what's
would be
wrong?
multiplied by 0, right?
Thank you.
So just before.
Is that what all you were going to say? Yeah. Good job, thank you. I did it quick and you all right, so we have 1/4 out here. Now remember, what is this called when we have just some matrix, right? And we have a number out in front. What's the matrix, or what's that number called again? Scalar. So essentially, once we get to this point, you know pretty quickly what your new A inverse is going to be. Pretty quick. We're going to take 1/4, multiply all the terms by 1/4. So go ahead and do that real quick. It's going to be pretty fast for you. All right, let's call on somebody. Let's call on somebody. Sonia, can you help me out? What's going to end up in here? Go for it.
I've got 1, 0,
Mhm.
and then negative 1/2, and then 1/4.
Perfect. Perfect. Everybody get that? You see it? That's not that bad, right? It's kind of this phrase, mnemonic device, that helps us remember to, switch the A and D and flip to be negative our B and C. That's the main part that's difficult. It's 1 over the determinant times that action that gives us our inverse. And I always think of when I see something complicated like this, especially with matrices, which is hard to conceptualize, I wonder how did somebody deduce this? Like the proof for that must be incredibly cumbersome. But we're going to use the mnemonic device until you guys get to college linear algebra. Then you have more fun with it. Whee, fun. All right, let's go ahead and do it for this one then. Let's go ahead and find our inverse of B. Go ahead and work it all the way up. We're going to have a fraction. We're going to have a matrix. We're going to work it out. Call me over if you're having trouble. Or you have a question for everybody? Everyone's- Yeah.
Do we really have do you know that A and A next to negative 1 equals I? So can you just like solve that? No.
Huh.
Because I mean, it's just 1 of negative.
Let me think for a second on that one. No, I thought I like that question. So you're saying since A times A the inverse is equal to the identity.
Yeah, can we just write plus minus a is equal to
Isn't identity 1, 1, 0?
The hard part with that is the inverse of multiplying a matrix would be doing division, and I'm not even sure how division within matrix
That's not possible.
items work.
Can't divide by 0.
But yeah, you have this.
we just do that and take out all this stuff.
Well, the thing is, you're going to be dealing with a situation of an equation with a matrix going on, which is what we're working to be able to do. So you can't, because in order to isolate the inverse of A, you have to multiply by the inverse of A. To move the inverse of A out of that and isolate. You see, in order to get rid of this and have it left over where it's A, you have to multiply A by the inverse of A. So you have to know that in order to negate it out.
Do you really do all that work and find it in this page? You could just
Well, we're not multiplying by a scalar, we're multiplying two matrices, which are going to have, the rows and the columns. That's just a lot to organize and teach it that way. You probably can do it savant style, but I'm not going to teach it that way. Yeah, it's very, very bright to think that, though. All right, let's go ahead and let's see. We'll take Alan, help me out. What did you put here for the determinant? It's 1 over something. Oh, I see. So what did you get? What did you get for your answer there?
0.
You got 0. Okay. So it was 4 times 1 minus 2 times 2. That gives you 0. Uh-oh.
0.
Well, it's actually not going to be 0 because 0 on the bottom of a fraction. So you know this was a semi-trick question. You know that there's no inverse, right? There's no inverse because we have a 0 in our determinant. There's no inverse. So in that case, if this was a matrix that was involved in a system of equation, as you'll see later, we wouldn't be able to solve that system in the same way because there's no inverse to multiply it by. This was just an example. Anytime you have 0 in the determinant, there's no inverse. You can't find it. Okay. Okay. What's the crux about that? What's the hardest part about that? Knowing that?
Just like knowing that there's no inverse versus like just stopping.
Gotcha. It's just when one of our fundamental rules is broken, in order to find the inverse, we know we can't find it. So think of it that way too. So you get to a crux, it can't go an impasse. So let's look at this real quick. What happens when we multiply these two matrices together? First off, can we multiply these together? What's the dimension of the first matrix? 2 by 2. What's the dimension of the second? 2 by 1. Let's see. Yeah, we can do it, right? And our matrix that we end up with is going to have how many rows?
2 by 2.
It's going to be a 2 by 1. You know that from the numbers that are left over if you're using that kind of spatial method. Okay. So we know we're going to get a 2 by 1. We're going to go ahead and do 2 times something plus 5 times something. And negative 1 plus 4. And then we'll put these in here. And let's see. We look here, we're going to end up with 2x plus 5y and negative x plus 4y. Where else do you see that on this board?
It's on the bottom, yes.
Woo! Oh my God. That's good. All right, so looking at this system of equation, the left side of it, those two expressions without the equal sign would be represented like so. We would take the coefficients. This is negative 1 and 4, 2 and 5. We'd put a matrix with just the coefficients multiplied by the matrix of x and y. And that would be equal, in this case, to the matrix of 4 and negative 2. You see, it's a method. When we get to it, once we get the inverse, we do it out, we're done. And when we get the final answer from doing this process, and you see, okay, x is 2 and y is 0, you see why it's useful. Especially if you had like 10 of these. If your system had like 10 different functions, Just think how fun that would be. All right. So watch how I'm going to work this out. I'm going to go ahead and move this up because it's probably hard for you guys to see. I'm just going to bring it over here. I'm going to end up with, we can rewrite this as 2, 5, negative 1, 4. It's multiplied by the matrix x, y. That's equal to the matrix 4, negative 2. See, we're going to be able to do this. Yes, Al?
How do you get 4 and -2?
Because that is what each system, in the system, those are what they're equal to. So essentially what I've done is I've created a matrix here, created a matrix from the coefficients, and I've created a matrix from our variables, which here we did this out, right? We did this out. We saw that we do end up with where we started thinking.
And so this is matrix form?
Correct.
Okay.
This is solving systems with matrices. All right. We'll be able to find, think about it this way. We're going to be able to find our x and y if we can get rid of this matrix. What did we just figure out over here? When we multiply by the inverse, we get the identity function, which is pretty much negating that out. Okay. So our goal right here, our strategy is going to be, we're going to multiply by, we'll call this matrix A, B, and C. We're going to multiply by the inverse of A. So in solving, I want you to look up here. Yeah, the solving says find the inverse. We know we need that. Number 2, left hand multiply. Why do I need to multiply on the left side of both of these on both sides? Why can't I multiply here and here? It's a real tiny technicality, but you actually remember this. With matrices, A times B does not always, or does not equal B times A. You have to have that order the same in both sides. Jackson, another idea?
No, that's
it. Okay. So what I'm going to end up doing is, I'm going to rewrite this. Over here, I'm going to find the inverse and put it in there. I'm multiplying that by A. We still have our B here. It's going to be equal to the inverse of A times this matrix C over here. I have to set it up like this because remember, what you do to one side, just in algebra, what you do to one side, you do to the other side. So if I multiply the inverse of A times A, that's going to negate those out. So on this side, I also have to do the inverse of A times C. You couldn't put it on the outside because you would get a different answer. You wouldn't actually be able to do it. If I put it over here, we have a 2 by 2, right? We have a 2 by 1. Can we multiply those? No, we can't multiply those. So you're going to come to an impasse if you try to do this. But because you know that the inverse is going to just, no, that's what you'll find. You'll have an impasse if you try to do it the incorrect way here. So let's find our inverse of A. Go ahead and find the inverse of A. And once we find this inverse of A, we're going to put it right here. I'll rewrite that. I know this is there's some complication to this lesson. I know. Okay, who's already done? Anybody already got it? Not quite. You got it? All right, Jackson, just tell me, what is going to be in this matrix right here?
4, negative 5, 1, and 2.
Because, what'd you do? You switch your A and your D?
Yep.
You change the sign of B and C. Perfect. It's 1 over, and then what are we just going to end up with down here? 13? Okay. You guys know how to find that. I think we've done enough examples. I'm going to put 13 right here. Everyone okay with that? Okay. So now I see that I'm going to go ahead and do this. All right, this is the inverse. This is a giant multiplication symbol. going to leave room for my fraction over here too. Now here's the deal. This is 2, 5, negative 1, 4. This is xy. This one's 4, negative 2. We're going to have the inverse multiplied on this side too. Right. So we were multiplying by the inverse. What happens with these two matrices when I do this? What happens with these two? They cancel out. Just like multiplying 2, when you multiply by 1/2, you get a negation of there. It's only equal to 1. So what we're going to be able to say with this is, look, goodbye, goodbye. You can trust that. Now watch what's left over. This is where it gets interesting. Can we multiply these two together? What do we have here? 2 by 2. 2 by 1. We know that if our insides match like that, we can do it. So I know that my new matrix over here is just going to be a 2 by 1. Okay. So I'm going to go ahead and just bring that up here. Our 2 by 1 is going to be 4 times something minus 5 times something over 1 minus 2. And then what are we going to put in here? 4, negative 2. 4, negative 2. So we work this out. 16 plus 10, 26. 4 minus 4, 0. You're like, when does this ever end? No, it does right now. That was a segue. So sorry, I was out of the screen. I worked out multiplying these two together up here. We knew it was going to end up being a 2 by 1. Up here, that works out to be 26/0. Jackson?
Where'd the 1 over 13 go on the left side of the equation?
The inverse includes the 1 over 13 times this modified matrix. So this, if I were to multiply this scalar in here, and then actually multiply these, it'd be exactly the same. You get your identity matrix. All right, you guys can do this scalar. Multiply that 1/13 in there. And we're about to see our answer. All right, Lincoln, what'd you get?
2. Yeah.
2/0. I know what you mean. Here's the deal. Watch this. The answer, 2/0. I know you probably don't like it, but you at least appreciate that all that complication actually finds the answer for us. Okay. I understand that feeling. Matrices have never been my favorite, but when things get really complicated, when you all get to your third year in college, and then your algebra and all that fun stuff, you're going to see this just amped up like crazy. Okay, but somebody tell me the crux of this. How about the crux? Is the crux finding the inverse? Not really. Does it make sense? Is the crux multiplying our inverse and our actual matrix to cancel it out? Does that part make sense pretty much? Yeah, pretty good. All right. Yes. Yes.
So we're multiplying these, so we track them instead of adding like up there where you do 4 times 4 minus 5 times -2.
Yes.
I just got confused because I thought it was adding. But
16 minus plus 10, 26. Well, I know the answer is correct. And I don't think I made that mistake. Hey, you know what? Let me check. I think you might be. That's right. One sec. It's plus.
No, 4 of them are only 5 deep in.
Oh wow. You know what? All right, everybody, listen up. Listen up. I'm not blaming because it's a really easy sign to mess up. But my student teacher taught this first period, and I just caught that thanks to Ellie. So Ellie pointed out that when you have the, what were we doing here? We were multiplying the inverse of A times C, right? We were just doing these two matrices together up here. You add together these. You add them, and you combine them. So when we get down here, I was going and basing this off the answer, but that I know is correct. But if we look at this, we have 0 for our bottom value still. But what happens up here? 16 minus 10? 6. So we don't end up with as nice of an answer. 6/13 and 0.
So it's negative 5 though, because in the matrix it's negative 5. So the top one is still negative 1.
You're right.
We still have a good answer.
We still get the same answer then, huh?
Yeah.
So I'm going to go ahead and go on the video and erase the last 2 minutes. And I hope you can do that, in your head. Sorry about that.
Why is it still?
The deal is that this was negative 5, and when I erased the subtraction, I messed that up. So here we have addition, but we get
Okay.
positive 10. So we do get 26. So we get 2. I just have to just erase the last couple minutes. The reason it changed initially is because I made the error up here. I made the error of making the subtraction, which now I see how it couldn't work. Dang it. Complicated lesson. This one part. See how it works?
Is there no home?
Andre.
So, did you add them to switch the subtraction? Or did you just add them?
The method that I was doing here was incorrect because I made the mistake. We need to add all these together. The 4 and the 5, remember, the 4 and negative 5 come from here.
Yeah.
But you're adding together those entries after you take the product. So that was the error I made, and I just compensated in a poor way. That's okay. All right, what should we say to all the matrices lovers in Brazil? Ciao. I say bye. Ciao. Okay, one sec. Portuguese for subscribe.
Oh, yeah.
Se inscrever. Se inscrever.
Oh, inscribe. Inscribe, not subscribe.
All right. Se inscrever. On 3. 1, 2, 3. Ciao.